Okay, Amira, welcome back.
Hello.
Okay. So Amira, at school, what topic are you learning in math? Did you have math class this week?
Yeah, I did.
So what was the first chapter topic?
We've just been revising things that we did last year, and then because of coronavirus, and then we're just gonna go over the new topics after.
Oh, I see.
We were doing some past papers, GCSE, on topics we've already done as practice.
Very good. So how do you do that? They just give you the papers and you have the practice, or the teacher shows at the whiteboard and just you need to follow the teacher? How do you
No,
practice?
we get given the papers physically, and then after we're all done, we go through the mark scheme together with the class.
I see. So can you solve all the questions, or maybe any question that you have to spend more time or you have to struggle with it?
The longer questions obviously you need to spend more time on, but most of it was fine. I made some mistakes, but they were like stupid mistakes, like reading the question wrong.
I see. I see. How many papers will you take? 3?
Let me check. I know that I
Paper
have to
1,
do.
paper 2, paper 3, right?
Oh, there's yeah, there's 3.
3.
I thought there might be 4, but there's 3.
Yeah, I think it's 3. And 1, you're allowed to use a calculator. Maybe 2, 1 without calculator. I see. Good. Yeah, Amira, maybe you might make a bit technical mistakes to improve yourself. Actually, your math is good. Maybe you should not actually, what my suggestion is, you should not be satisfied with your current, how to say, your knowledge. Since you can, you should learn as much as you can, because later, I don't know, you'll not have that much interest in the future. In the future means after like 25 years or 30 years. And especially, we actually learn a lot when we are like between 14 and 22 or 23. What I see, because after that, there will be more distractions in your life. After you graduate, maybe you need to look for a job. And after that, you will have different friends and different people, all the distractions. And that's why now, as much as you can, you should learn. If things are so easy when you're practicing GCSE papers, questions are so simple, you know that you can do that. Okay, just do it and cross out the questions. When you look at the questions, if the idea does not come, maybe we need to put some kind of mark on it, or maybe just circle the question, so that later when you have to practice, just you need to go through those questions. And that's much enough, I think, because after all, GCSE are very standard questions. They do not ask a very different question that you have to think a lot, or you have to use a combination of different concepts, because like knowledge-based exam. And that's why only practice, practice. Practice doesn't mean that easy question you have to solve again and again. No, have a look. If possible, you have to go through all the papers. And when you look at the question, immediately, if the idea doesn't come, you have to practice only those questions, because as you know, they ask a lot of very easy questions at the beginning, like addition of two fractions, or simplifying very simple algebra expressions, or finding the area of simple geometric figures, something like this. I mean, you don't have to practice those questions, I think, again and again. Maybe one also or 2 times, that will be enough. Anyway, that is what's actually how I studied math when I was a student at high school and university. I'm preparing for university. So Amira, now let's get back to our topic. We were talking about matrices in the previous session. Now you have some idea about the inverse of a matrix, and here we are talking about only 2 by 2 matrix, and also we actually obtain a formula how to find its inverse, and also we know the condition when a matrix has inverse or not. For a 2 by 2 matrix to have an inverse, its determinants should not be equal to 0. It must be different from 0. In general, it is true, because for a matrix to have inverse, its determinants must be different from 0. Of course, when it is like 3 by 3, 4 by 4, finding determinants is a bit different. Actually, here we're talking about only 2 by 2. Anyway, now we will see, I mean, we will apply, that's how to say, that idea that we have just obtained, or that we have just seen, to solve the system of linear equations. As you know, in chapter maybe before, I don't know if we have studied with you or not. So this kind of equations, we call this system of linear equations, right? Or simultaneous linear equations. So we are given two equations here. It's like the first example. The first one is 2x plus 3y equals 8, and 3x plus 6y equals 15. So if I ask you to solve this, we know that immediately, maybe by using substitution method or elimination method or graphical method, we can solve this, right? It's fine. But how about if you're given this kind of system? How many variables we have? A, B, C, D, E, 5 variables and 5 equations here. And if you try to use elimination methods, does it work? It works, but it involves a lot of calculation. Actually, maybe you need to fill at least 2 A4 size paper, or at least 1. Anyway, that's why mathematicians thought, okay, if this system has solution, is there any other way, actually, so that we can write algorithm, so we don't have to do those calculations. We just write the algorithm and give it to the computer, and it must solve this. To do this one, we have to develop a technique. The technique is matrix methods. And again, here I can just simply write the whole system in this form again. I can just write it as A times X, that's equal to B. Actually, these are not numbers. These are vectors or matrices. All are matrices. This one, X, is column matrix, B is column matrix, this A is just a matrix. Since here we have 5 variables, this A is 5 by 5 matrix. This X is, actually, what are the components of X? X is something like this. Here we have A, B, C, D, E. These are the variables, A, B, C, D, E. So that is 5 by 1. And how about this one? B is a constant term whose components are -1, 3, 12, 41, 24. So that is also 5 by 1. As you see here on the left hand side, if you multiply A by X, 5, 5. Okay, that means that we can multiply this. The resulting matrix will be 5 by 1. Okay, to solve this system, actually, we are practicing here. And you may, because when we're just practicing for only 2 linear equations, students may think, okay, we know that easier method, why don't we just apply this? Actually, we're not talking about solving only 2 systems. We are talking about a bigger systems. And here, just we are trying to get some basic intuition about this idea. Okay? Okay, now we will just use these ideas to solve the system of linear equations. Solve the equations using that matrix. How do we do that? First, again, if you just write them together, 2x plus 3y, that's equal to 8. The second equation is 3x plus 6y, that's equal to 15. So in compact form, I can just write it as this. Here we have 2, 3, and 3, 6. And here we have x and y. On the right hand side, here we have 8 and 15. Okay. So as you just multiply again, I will get exactly this system. Now I have just expressed this using matrices. Now if I just denote this one by A, here we have A, this one by X, here we have X, and this one by B. And in the previous examples, we have just studied how to solve this system, right? If we assume that A has inverse, let me just check immediately. What is the determinant of A? That is 2 times 6, that is 12, minus 3 times 3, it is 9, that's equal to 3, is not equal to 0. That means that the matrix A has inverse. So to solve this system, we should multiply both sides from left by its inverse. So here we have A inverse A, here we have X equals A inverse and B. Then what is the solution of the system? That's just equal to A inverse B. So to do this one first, we should find the inverse of A. Okay, determinant equals 3. Then what is A inverse? A inverse is 1 over determinant of A. That's equal to 3. Okay, here we have 3. And here we have to interchange this A and B. So here 2, 6. So here we'll have 6 and the minus 3 and minus 3. And here we have 2. Or that is equal to 6 over 3. 2, negative 3 over 3, negative 1, negative 3 over 3, negative 1, 1 over 3 times 2, 2 over 3. That is A inverse. Then the solution of the system, actually that is X and Y, that is equal to A inverse times B. A inverse is this, 2, negative 1, negative 1, 2 over 3. And how about B? B is, what is B? 8, 15. That is 8 and 15. Which is equal to 2 times 8, 18. Negative 1 times 15, negative 15. The sum is 1. Negative 1 times 8, negative 8. 2 over 3 times 15, it is 5, 10. 10 minus 8, that is 2. So dots, dots, dots. The value of X is 1 and the value of Y equals 2. Now if you just check this, X, 1 and 2. 2 times 1, 2. 3 times 2, 6. 2 plus 6 equals 8. The second equation, 3 times 1, 3. 6 times 2, 12. 3 plus 12, that's equal to 15. That is one application of, what is it, matrix in solving system of linear equations.
Okay.
Amir, do you always understand the new topics this much fast, or this is so simple for you?
No, not really.
Usually when I teach this kind of concepts, for example, I teach linear algebra, of course, not this 2 by 2, but maybe 3 by 3. Not everybody understands in the first, how to say, in the first lesson or in the first explanation. They just look at the whiteboard and actually they just look like puzzled, or they don't understand anything. They ask their friends, even in the exams they fail. Maybe your math is very good. I don't know, you practice a lot of questions, but you are a humble girl, I think. And that's good. Actually, if you really continue studying like this, it will help you a lot to learn other subjects in the future. And the future means when you go to the college or when you're studying for A level.
Okay.
Okay, Amir, can you do this question? Since you have the idea, there's not much to learn here. Just we have to apply those rules.
Okay, I can try. I'm not too confident yet.
Because when you just write it down, you know, it's, I don't know, human nature. We understand more, and that is not easy to forget. Because sometimes we just watch things and we think that we can do that, but when you practice, you learn much better. 9664. No, I mean, at first, can you just write the equation in matrix form? Okay, 9664, and next to it, write X and Y equals 1430. No, this thing, can you just erase this one first?
Oh, okay.
Because you're going to write in this form, right? A times X is equal to B. Okay, that's our A. What is X? That is X and Y. in vector form or matrix form. No, like this, right? I mean, here we have the
Okay.
first
Yeah.
one, and like this. In constant terms.
Is it like that?
Yeah, it's like that. And one more time, just write like this. Here we have A, and just write so that we know what you are doing here. A times X equals B. From here, we're going to find X, right? X equals A inverse times B. Then here, find the inverse and substitute here and the answer.
So the inverse of that.
You can write, Amira, because you are practicing for the first time, you can just write the inverse of this, like this, 9, 6, 6, 4, inverse, and here we have 14 and 30, and calculate its inverse here, and substitute, and evaluate this.
Is that right?
Well, 36 minus 36 is 0.
0, yeah.
So what is 1 over 0?
Oh, is it just 0?
1 is divided by 0 is equal to 0. We cannot divide it, right? Because we don't have 0 division. Yeah. It's not defined. So that's why, because here, okay, after writing this one, A equals that thing, this one is A. First, you need to find the determinant of A, that is 36 minus 36, that's equal to 0. That means that it doesn't have inverse. If it doesn't have inverse, we cannot use these methods. So actually, even A level or GCSE, they may ask these questions. So what do you do then? So actually, if determinant equals 0, so that means that we cannot solve this by using this method. Why? When actually we have this situation, we have two possibilities here. Number one is the system has no solution, or the system has infinitely many solutions. Because if you just consider that we know that the graph of this equation is a straight line, the graph of this equation is a straight line, only this matrix method is or can be used if they intersect each other at one point. That means that they have one solution. And if these two lines are parallel, the second case, or they are collinear, overlapping each other, that means that their equations are exactly the same. At the time, that means that this parallel means they have no solution. And the collinear means they have infinite solutions. So what do we do here? Actually, just using our usual method, you have to solve this. And that means that write it next to each other. And if we divide both sides by 3, we have 3x plus 2y equals 14 over 3. And the second equation, divide by 2, 3x plus 2y is equal to 15. On the left-hand side, the expressions are exactly the same. On the right-hand side, 14 over 3 and 15. The same expression for the same values, they cannot produce two different values, right? So that means that these lines are parallel and they don't have, what is it? They do not have any solution.
Oh, okay.
I mean, it's actually on purpose is put here so that if you have such thing, for example, I don't know, they may just ask you to write the conclusion. Since A has no inverse, that means that we cannot solve the system by using the matrix methods, and by just using the using the usual methods, maybe what is it, elimination method or substitution methods. As you see here, this system has no solution. Okay, that means that what I'm trying to say here is if determinant of A is equal to 0, that means that either the system has no solution or it has infinite solutions. But instead of this 14 over 3, if we have something like this, for example, let's say here we have 9, let's say we have 9. Then how many solutions would it have? It will have infinitely many solutions because 3x plus 2y equals 9 is just collinear. That means that they have infinitely many solutions. Okay, let's see the next question. I mean, let's see what we have here. It's also similar. In this case, I think because 3x plus 2y equals 7, right? 6x plus 4y equals 14. Okay, if you just simplify this, here we have 3x plus 2y equals 7, 6x plus 4y equals 14, and matrix A, here we have 3, 2, 6, and 4, and determinant of A equals 3 times 4, 12, 2 times 6, 12, that's equal to 0. That means that we cannot solve the system using the matrix method. And now if you solve this, as you see here, if you divide the second equation, both sides of the second equation by 2, here we get 3x plus 2y equals 7. The second one is 3x plus 2y is equal to 7. That is another example. Determinant equals 0, and actually we have exact two equations, same equations. That means that, and this equation has, or can just write this system has infinitely many solutions.
Oh, okay.
Okay, because usually when we talk about the system of linear equations, we have only three possibilities. We don't have actually the fourth possibility. The first one is either it has one solution, or it has no solution, or it has infinitely many solutions. We don't have the fourth case. Actually, we just actually here considered all of these three cases. When it has one solution, we can use matrix method to solve this. When it has infinitely many solutions, we should just use the elimination method to solve the system. When it has, again, infinitely many solutions, actually we should just use either elimination or substitution methods. Okay, I just put this to give you some idea. Another example for you, Amira. Now try to solve this question. And actually we'll solve together. Just solve it. If you need help, I will help you. Otherwise, you will do all yourself. We are given P, Q, R. Okay, first we need to find the inverse of P and inverse of R. And after that, we have to use these things, I mean, information to find the matrix M in the given equation. Okay.
What do I do from here?
Okay, now, actually, it's not determinant, right? You found actually inverses.
Yeah.
Right? Can you just write P inverse and R inverse? Okay, first, before we substitute their values from this equation, I mean, can you just leave this M alone on the left-hand side? How do you solve for M? No. In matrix, we never actually studied division, right? We don't have division operation for matrices. So like here we have P, M, R, and equals, here we have Q. But we can do the same operation to both sides. Here I can multiply both sides by the inverse of P, also here the inverse of P. And on the right, we can multiply by the inverse of R. Here we have the inverse of R. So these two things is equal to I, that's equal to I, only M left here. So that is P inverse, Q, R inverse. Then we can substitute and multiply the matrices. I mean, to multiply this kind of matrices, if we have a common denominator here, we can just keep this outside the matrix. It's much better. As see here, the first one, 1 over 11, right? I can just take it out. And the second one, 1 over 8 is a common denominator. We can take this out. Then we will have here something like this, 1 over 11 from the first matrix. From the second one, 1 over 8. So, because they are just scalars. So here we have 4, 1, 3, negative 2. And the second one, 1 over 8 is out. So here we have 4, 2, minus 6, and 1. Much easier to multiply. After we multiply this, we can just multiply each component by 1 over 88.
Okay. Yeah, so I'm just gonna write the first multiplication here, and then I'll do the final one here.
Mm-hmm. How do we get 29?
That's 24.
24, okay. Four.
So that is.
Yeah, you can just write in front of 1/88. We can just keep this. We can multiply it by 1/88 after we multiply by our inverse. So now what we have here? Here we have 1/88 times this matrix, right? So now we should multiply this by, what is it? R inverse, by R inverse. So we don't need this row, so we need more space. Okay. You can just write here 1/88, like here. Okay.
Oh, okay.
So now P inverse Q. Now we need to multiply this result by R inverse, right? Can you just do from here?
Oh.
That's right. P inverse Q times R inverse. P inverse Q R inverse. And P inverse Q is 1/88 times 10, 9, 24, 4. And also that R inverse, the common denominator is 11. You can just write this outside the matrix. Maybe in front of that 1/88. You can just write it there, 1/11. And that is 2, 1, -3, 4. -20 minus 27. Okay, it's -7. Okay.
That's what I thought. Yeah.
Yeah, that's correct. I mean, just to get used to it, because matrices are a little bit different than the real number, especially multiplications. Okay, so let's see what we have here. This is all the system. Okay, 2 slides left. Okay, we could have finished them. No problem. Okay. 2 questions left. I mean, we can solve this maybe next time. Let me just see this. Write down the inverse of this. You know how to write this. And use it to solve the simultaneous equations. And here just need to bring it to the standard form and solve this. As 3 mangoes and 2 kg of bananas, the word problem. Okay. I mean, that much is enough, I think, about matrices. And maybe, I don't know, if you have some free time, I may give you another exam after maybe 2 or 3 weeks. At the time, you'll practice, or next week also maybe 5-10 minutes, we'll practice a few questions. And after that, we'll talk about application of math. That is, what is it, about Actually, math has a lot of application. You will see some that is used in business, tax, in the evaluation of utility bills and electricity bills and the exchange, I mean, currency exchange, something like this. Anyway, I think next week, if we meet, we will talk about that chapter. It's quite a big chapter, but I think you know those things, but just we need to practice a few questions. It will be some kind of revision for you, and they will continue. Okay. I'm going to thank you very
Okay.
much. See you next Sunday then. Okay.
Okay. Thank
Good
you.
luck in your
Bye.
studies. Bye bye.